What's up guys, Shawnthebro here, and in today's episode of the third-person action RPG tutorial series, we are going to be going over Ragdoll Physics Part 2 in our game. So specifically, if we go and perform our Ragdoll animation by dying, we are going to respawn, things are going to look as normal, we're going to be doing our get up animation, and we will be able to control our character again. And this character will have regular physics, we actually have our animations, they're in the right spot, and they're no longer ragdolling. Additionally, we're going to have a few bug fixes for things such as being able to enter and exit the inventory menu using either of our options and still control the character, as well as equipping weapons and equipment on our character and having them attach properly to the character, which was broken when we changed to the root motion animation if you didn't do a few extra steps along the way. So all this behavior will work again after today's episode. Now, if you want to get caught up in the series and check out how we've done everything from locking onto our opponents, equipping weapons, creating quests, and a lot more, I recommend checking out the entire playlist for the third-person and action RPG tutorial series, which I put right here in the top right corner of your screen. Alternatively, if you only care about the Ragdoll physics, I will link you to the previous episode of the third-person RPG tutorial right here in the top right corner, and that is Ragdoll Physics Part 1. That is where we actually started ragdolling upon death. And with that out of the way, we can go ahead and get started. So first things first, this is a code and blueprint tutorial series. Pretty much everything is going to be in the code today. So we want to go there to start, and specifically we want to go to our third-person tutorial character.cpp. Since we enabled ragdolling in the death function, I want to disable ragdolling in the respawn function. So I'm going to scroll down to my respawn function, which is right here. Now these 4 lines I have right here are what's going to actually disable the ragdoll. There's a few things we're going to have to determine so that we can get all these values correct in here, but the actual logic is very simple for today's episode. So first things first, we are getting our mesh, which is our skeletal mesh for our character, and we're calling set simulate physics on it false. Again, in the die function, we were setting simulate physics to be true. At this point, we don't want to simulate physics anymore, so we're setting it to be false. Next, we're going to set the collision profile name for the mesh to our default value. For me, that is character mesh. This may not be your default value. We'll have to check what our blueprint base character is. So my base character BP has a default collision profile of character mesh on the skeletal mesh, and that's why I put it in here. Note that this is text, so you need to match the name up exactly as the profile has it. I'll show you that when we get back into the editor. After that, I'm actually going to reattach the mesh to our root component on our character, because the issue we were running into at the end of the last episode is that we would enter the ragdoll, and then when we respawned, even if we were disabling the ragdoll, the character was stuck over at the position that they had ragdolled, and while they were influenced by our actions as the player, like I could trigger the sprinting animation, the jumping animation, the mesh wasn't actually following or attached to the capsule component of the character in any way anymore. So to fix that, we're going to call getMesh attach to component. For the component that we're attaching to, we're going to get the root component. The root component of our character is the capsule collider, or the capsule component. That's the root of our character, and that's where our collision is. We want to make sure we attach the skeletal mesh back to that. Another thing I'll show you when we get back into the engine is whatever your skeletal mesh was attached to in the blueprint is what you'll want to attach it to again. So you may not want to attach it to the root component. You may have a different parent component that you want to attach to. So I'll show you how to find that as well. For the other parameter I have here, that is the F attachment transform rules called attachment rules. And so this is how we're going to attach it. I'm going to attach it by snap to target not including scale. So F attachment transform rules, : snap to target not including scale, and this means the location and the rotation will match the root component in my case. The scale, however, will not. I'm not including that. Feel free to use the scale if you want. The scale should not be adjusted by the ragdolling, but the location and the rotation will. So that's why I've chosen this one. If for whatever reason your scale does change when your character ragdolls, you could change this to snap to target including scale. Lastly, we want to set our mesh to be at the proper location and rotation if there was an offset from the capsule component. So in my case, my skeletal mesh was not in the same location and rotation as the capsule component. It actually had a relative location and rotation. And so since I've reattached the mesh at this point, I had to match those offsets. If your skeletal mesh doesn't have any offsets or relative locations, rotations, or scales from the root component, then you don't need to do this line. But I will show you how to get these values when we go back into the editor as well. So we have get mesh, set relative location and rotation. Location is an F vector, rotation is an F rotator. So F vector, and we pass in our X, Y, and Z values. For X, I have 0.0F, Y, I have negative 10.0F, Z, I have negative 100.0F. For the rotation, I have an X value of 0.0F, Y value of 270F, and Z value of 0.0F. If you needed scale, based on the previous comments that I was making, you could call set transform. Set relative transform. And then pass in a transform which has, of course, the location, rotation, and scale. Now that we have this behavior in the respawn function, we're a lot closer to the goal that we need to be at. However, I need to go into the editor so that we can make sure we have all of our values correct based on what we set up in the base character BP. Let's go ahead and load the editor. Now that the editor is back open, we can go into our base character BP. And if we go to our viewport and then go down to our skeletal mesh, right here, mesh, character mesh 0, skeletal mesh component. Now first things first is the collision profile. So if we scroll down on the skeletal mesh to the collision section, right here, we have this collision preset section. The text that's in this drop down is the collision profile name. When starting the ragdoll, we were changing this name to be ragdoll. So when disabling the ragdoll, we want to reset it back to the default value, which is character mesh. So collision profile name, character mesh. You could assign this to a variable if you want, but if you're not changing the profile a lot, then you don't need to. Next is the parent element, or the parent component. So this skeletal mesh is a child of the capsule component. That is why we use get root component, because the capsule component is our root, and that's what we want to attach it to. Attach to component. Remember, we saw our parent was the root component. Lastly, we have our relative location and rotation. So if we scroll up to the top of our skeletal mesh, we have this transform section, and in here we have location, rotation, and scale. My scales are all 1.0. That's why I said I don't need to mess with the scale, but you may need to, so keep that in mind. My location and rotation, however, are a little bit different. So for location, I have X, Y, and Z. Y is negative 10, Z is negative 100. Since I did apply a negative relative location here, when I'm reattaching to my code component, I need to make sure I save those values to put it in the same spot. Otherwise, it will come up here, which would be fine if that's where our capsule was. So instead, I want to make sure I apply those same values to my location. Rotation is the same deal, so we have the roll, the pitch, and the yaw. My character has a 270 yaw to face the arrow, or the direction of the capsule component, and so I want them to still do that when they respawn, and so that's why I'm changing the rotation to that value. And for location and rotation, we have 0 on the X, negative 10 on the Y, negative 100 on the Z. The rotator looks a little bit different, and that's because if you look at what makes up an F rotator, it's actually the pitch, the yaw, and the roll. Whereas in the Unreal Editor, it was the pitch, the roll, and the yaw. So we want to make sure we keep our values consistent here. We were 270 degrees on the yaw. So since yaw appears secondly in the F rotator, we need to make sure that we have 0, 270, 0. While we're here, let's fix the bug with weapons and equipment not attaching properly for our root motion skeleton. I never covered this, but remember we changed our skeleton at some point in the series to support root motion. We need to make sure that we add our sockets back if we want to actually support armor, helmets, and weapons. So this very well may be different for your model, but make sure you add your chest socket back, spelled just like this, or whatever you called your socket that you're looking for in your attached behavior. This is in our base equipment BP logic. Additionally, I have one for our helmet, which is here under the head bone. I've called it head socket. You don't need these preview meshes like I have. I've just put them in so that I can visualize and make sure the socket's in the right spot. Here we have head socket, also in the base equipment BP. Then, on one of my finger bones, I've added the weapon socket. This is handled with attachment in the base weapon BP. And lastly, in my right hand, I've added the right hand socket so that I can deal damage with collision on my right hand. You should probably do the same thing with your left hand if you want to do collision there, and we actually do. So I've added it here, left hand. If you add all these sockets back to your skeleton, then everything we have in this series so far regarding sockets will work again on the new skeleton. I just never specifically told you guys to do that, so my apologies for leaving that out. Let's also fix the bug with the inventory window. There was a bug where if you didn't press the back button for your inventory and instead press the toggle, which is the same button that you use to create the inventory window, you would not be able to control your character after closing the inventory window. So let's go to our inventory window widget, and I want to go into my graph. In event construct, we have some logic toward the end here where we listen for input action. We were listening for the input action menu back at one point to call return from menu. When we do this, this is like pressing the B button on an Xbox controller or a circle button on a PlayStation controller. We're saying we want to go back and exit this selection that we're in, or this menu that we're in. I also have allowed opening and closing the menu with the same button, or a toggle button. We want to also include this listen for input action here where we do all this behavior. And more importantly for this episode, setting is menu open to be false, because when menu is open, we can't do things like move or jump. That is what was restricting our movement. So we're going to add another listen for input action node. And in this one, we want the action name to be the name of our toggle. For me is open close menu. You can find this in your edit project settings, and then in input, and then open close menu. Additionally, if you're using enhanced input, you can do the same thing. You'll just have to handle it that way. We will be covering enhanced input in this series, so you don't have to worry. For the event type, we're using IE press because it's when we press the button that we want to trigger this. And in this case, I am checking consume. Consume makes it so that once this event runs from this input action being triggered, other widgets and other actors listening for that input action won't be triggered. This is useful because when we disable the menu using this button, since we're setting the is menu open to be false, the logic on our base character BP for pressing open close menu would actually reopen the menu. So if we go to base character BP and go to our open close menu input action here, as long as we are not dead, inventory menu reference would not be valid at this point. So we would go ahead and create a new one. And when we create a new one and add it to the viewport, we're going to be in the same spot that we were before pressing the button. So you get stuck in an infinite loop where you can never close the inventory window. We want to make sure we consume the input here to avoid that. Then the callback, you can just drag it into the same thing that the menu back was doing. Anyway, guys, that's all I got for you today, so thank you so much for watching. If you enjoyed this episode, please subscribe. It does more for myself and the channel than anything else you can do, and is completely free. If you want to support me further than that, you can go ahead and check out the Patreon, YouTube membership, and Discord subscriptions, like all the kind souls you see on the screen. Not only have they benefited the channel greatly, but they get rewards for doing so as well. If you ran into any problems while following this tutorial or any of my tutorials, feel free to join the Discord community. There's a link in the description, and that support is completely free. Anyway, guys, that's all I got for you today, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.